So these questions require to use the superposition principle to determine the total current passed through the R3 and also the voltage across R3. So we're going to redraw this circuit. Okay, we only need to draw one voltage source contribute to the current passing through R3. So the step one is that we're going to calculate the currents contributions from V1. Okay, so this is our V source here. So we're going to calculate this. So we redraw the circuit here. We have this minus positive. This is our V1. Okay, and then go in here. So in this case, this will be replaced with ideal wire, and then we have this resistor. This is our R2 resistor, and then we have another resistor here connected to this positive terminal. This is denoted as R1. From R2, we split one resistor over here. This is the R3, and then connect it back here. Okay, so this is 20 volt. Here we have 1K, and then here also is 1K. Here we have a 2.2K. Okay, so now we want to find what is the currents, okay, from this voltage source V1 to R3. So let's assume that the current flow to this R3 over here, okay, denoted as capital I1. Okay, we want to find what is the I1. So now what we can do is we can use the current divider circuit. We first find what is the current flow in this. Let this denote this current flow is I. So what is I? I have to find I. First we need to find the network resistance of this, okay, this equivalent circuit. So for this equivalent circuit, what we have is we know that this equivalent circuit, let's denote this as I give some node here. Let's say this is node A, so the equivalent circuit at the node A is equal to R2 and R3 are in parallel. So that means from this case we know R2 is in parallel with R3, right? So that means the IEQ, okay, the IEQ for this is equal to R1 plus RA. Okay, so that means R1 plus R2 parallel with R3. Okay, so we can substitute the value. R1 is 1K, and then R2 is 1K, then parallel with R3, 2.2K. Okay, so if you calculate these values over here, then you have 1K plus 2.2 divided by 3.2K. So in that case, you get 1.69 kilo. Okay, this is IQ. You can find the current I, capital I value is equal to 20 volt divided by the IQ. Right? So we have a 20, IQ is 1.69K. So the current is 11.8 milliampere. Okay, so this capital I here now is split into two. We can use the voltage divider to find the I1. So the I1 is equal to the I multiply using the voltage dividers. Then we have R2 divided by R2 plus R3. Okay, so this is 11.8 milliampere. Then times R2 is 1K. So R2 plus R3 is 1K plus 2.2K, then you get 3.2K. Okay, so from this, you get the current passing through R3 contribute from the voltage source is 3.69 milliampere. So now this current here is flowing downward. Okay, it's flowing downward. So that is the current contribution from the V1. Okay, from the V1. So next we want to calculate the current contributions from the V2. From V2. So from V2 we're going to draw the redraw the circuit for this V2 here. Okay, so we're going to shift this to the side. Okay, now the next we want to calculate the current contributions from this V2. So from V2 we redraw the circuit here. So this is our minus positive. This is a V2, 15 volt, and then connected to a resistor here, which is R2, 1K. And then at this junction node here, that denote this as junction node C. Now it's the one is going up. This is R1, is 1K. And then now it's split into two. This is our R3, 2.2K. And then it's flowing down. So where this R1 going here is going connected to this, right? Okay. Right. So now I want to find the current path of R3. So let's assume that the current is passing in this direction upward, and we want to find this I2. Okay, so I2 is the current contributions from the 15 volt, from 15 volt. So in this case, what we can see here, we find the IQ, we denote that the currents go to this R2 is capital I. Okay, now how to find the capital I's? Now in this case, when at the junction C node is split into two paths, that means R1 is parallel with R3. Okay, so we find the IEQ in this circuit. So IEQ in this circuit is R2 plus, then we have R1 parallel with R3. So R2 is equal to 1K, R1 is equal to 1K, then parallel with R2, R3, 2.2K. Okay, so from this you get the IEQ value, which is 1.69K kilo. Okay, so from this 1.69 kilo ohm, you can find where is the capital I value, which is 15 volt divided by 1.69K. Then you get the currents for this is 8.88 milliampere. Okay, so after you get the 8.8 milliampere, then we know that this I here is 8.88 milliampere. So this will go to this junction split into two. So you can use the current divider to find what is the I2. Okay, so I2, you use the current divider, is equal to 8.88 milliampere. Okay, so split into two. So here is the 1K divided by 1 plus 2, you get 3.2K. Okay, so in this case, we calculate, we get 2.7. We get 2.78 milliampere. Now this I2 is flowing upward. Okay, this is flowing upward. Okay, so now we have two current, I1 and I2 already calculated. Okay, in this case, we have this 3.9, 2.69, 3.69, and 2.78. So the net currents for this, net currents, in this case, I net is the current passing through for R3. So that is the I1 minus I2. So I1 is 3.69 minus 2.78. You get the net current for this, give you 910 microampere. Okay, so this currents is net currents is flowing downward. Okay, net current is flowing downward. So after you find the net currents, so the next question is what? Find the voltage across the R3. So you have the net currents. So now we know that this net currents go to this R3 is 9/110. So it's 9/110 microampere. So the voltage is simple. Voltage is V okay, voltage across R3, okay, across R3. So this is equal to V equal to I we don't have 1910 microampere times the resistance 2.2K. So we get the voltage. Okay, in this case, roughly we get voltage about 2 volt.